Dear students, so today we'll study about electricity. See, this chapter is normally taught in 10th standard. So we will go for some concept of electricity. I hope you will enjoy. So electricity, you know, the first thing in electricity when we study is charge. The symbol of charge is Q. The SI unit, Coulomb. So this name is kept in the honor of scientist Coulomb, who gave Coulomb's law. Now, in charge or electricity, the most important element or part is electron. The charge on each electron is E equal to minus 1.6 into 10 to the power minus 19 Coulomb. Okay, so if charge on one electron is this much, and if there are n electrons, n is number of electrons. Then Q equal to NE. Q is total charge. So total charge is number of electrons and charge on each electron. So I hope you understood about charge. Now we'll study about electric current. So how we define the current? The rate of flow of electrons or charge. The rate of flow of electrons or charge is known as current. Rate of flow of charge or electron is known as current. So current, electric current equal to charge upon time, because it is rate of flow of electron. So if current we put as I and charge symbol is Q and time is T, then I equal to Q by T, or we can write Q equal to NE. So what is current? I equal to Ne by T. This is your formula to calculate current. Now SI unit of current. So SI unit of current is ampere. So this name is kept in honor of scientist Ampere. There are some small unit also in current because ampere is very large unit. So 1 milliampere is equal to 10 to the power minus 3 ampere. The another unit 1 microampere, 10 to the power minus 6 ampere. So this is the definition of current. I hope you understood. Now we go for another term which is voltage. See, without voltage there can't be any current. See, the theoretically voltage is something and practically is voltage is not important, voltage difference is important. Or we can say potential difference. Voltage difference and potential difference both are same thing. In some books it is written as voltage difference, in some books it is written as potential difference. So if you are talking of voltage or potential, it is same thing. Now the what is the absolute definition of voltage? At first I will write, then we will go for the voltage difference, what exactly voltage difference is. So voltage, the amount of work done to bring unit positive charge from infinity to some point. It is known as voltage at that point. So the amount of work done to bring unit positive charge from infinity, infinity means much far, far and far, to some point. It is known as voltage at that point. So what is voltage? Voltage is nothing but work done upon charge. So here we are calculating basically the, because unit positive charge. So whatever work done is there, we will divide by charge to find the unit positive charge. So in symbol we can write work done is W and charge is Q. Now the SI unit of voltage, SI unit is volt, and this is equal to, the unit of work is joule and unit of charge is coulombs. So volt means joule by coulomb. So 1 volt is equal to 1 joule upon 1 coulomb. So that is volt. So 1 volt we can understand like this. Suppose somebody asks you to give a definition of 1 volt. What you can say, that if we bring 1 coulomb charge from infinity and whatever work is done, so that work will be equal to 1 voltage, because 1 coulomb means 1 unit, 1 unit So if C equal to 1, so 1 volt equal to 1 joule. So if charge in 1 unit, then whatever work we will do, that will be equal to voltage. Now the one more term when we study electricity is resistance. So what is resistance? In normal words, for understanding, resistance means to resist something. Here the resist to flow of current. So resistance means the property of conductor to resist the property of conductor to resist the flow of current is resistance. We symbolize the resistance or put in a picture is like this, and symbol is R. The SI unit is ohm. It is in the honor of scientist Ohm. The SI unit of resistance is ohm. So we write like this, or there is one symbol ohm like this. So we have studied here, or I taught you the four properties of four connected terms: charge, current, voltage, and resistance. So when we talk about electricity, these all four terms are very important. Now we'll go for Ohm's law. Ohm was a scientist who gives this Ohm's law, and all electricity, most of the electricity anywhere for any machine or any circuit follows the Ohm's law, except certain exceptions. The current in a conductor is directly proportional to voltage difference. The current in a conductor is directly proportional to voltage difference between its ends, conductor ends. So we can write V is proportional to I. As the voltage will increases, current will increases. Now we remove this proportional sign, then we put a constant, and that constant is R. So V equal to Ri, or normally it is pronounced as V equal to IR for easiness. This is Ohm's law, where R is resistance. Through this law we can find out I also. So I equal to V by R, or R also V by I. So this is a law, Ohm's law, applied or applicable in most of the calculation, most of the circuit, and we will study in detail about this. Now I will put a small circuit to make you understand how the circuit is formed and electricity works. So this is the a small circuit diagram. V is the voltage. Now this shows the current flowing in the circuit. R is the resistance, and this is the switch. So this is open switch. If I put like this, the switch is closed. So when the switch will close, there is a voltage, so current will flow. So suppose I current flow, so this ammeter will show the current I. As the voltage increases, current will also increase. So the graph between voltage and current will be like this. So if we increase the voltage, current will increase, and it will be this straight line. So you can say the graph is linear graph. So this shows that voltage is directly proportional to current increase, or current is directly proportional voltage. As voltage is increasing, current is increasing. I hope you understood. Thank you.